Welcome to this MRC PCH revision video. In this video, I'll explain the QRS axis and how to calculate it. So at the end of the last video, we derived the hexaxial reference system by converging all 6 of the limb leads centered on the heart. It can be quite a tricky diagram to memorize. Personally, I prefer to reconstruct it from first principles using Einthoven's triangle and the augmented limb leads. Some people prefer to use Leonardo da Vinci's Vitruvian Man as a reference to remember it. Still other people have danced to YMCA to remember it. Whatever system works for you, works for you. So let's take a look at the system in a little bit more detail. I personally find it easy to remember it as 2 semicircles with the flat edge being represented by lead 1. We take lead 1 at 0 degrees. If we count clockwise from 0 degrees, the bottom semicircle is divided into positive 30-degree segments like this. So plus 30, plus 60 or lead 2, plus 90 or lead AVF, plus 120 or lead 3, plus 150 and plus 180. Moving anti-clockwise, the top semicircle is divided into negative 30-degree increments. So minus 30 or AVL, minus 60, minus 90, minus 120, minus 150 or AVR, and minus 180. This is important to interpret the axis properly on an ECG. So what do I mean by axis? Well, axis is simply the overall flow of electricity within the heart. Think of it as the average direction of all the electricity flowing in the heart per beat. So we know that the electricity is generated in the sinoatrial node and flows down the interventricular septum towards the apex of the heart, roughly like this. So you might expect the normal axis to be in roughly the same direction as lead 2. Of course, in real heart, there's a range of normal values, and the normal range of the axis depends on your age. But for simplicity, let's have a look at adult values for now. So the normal axis in an adult will be anywhere between minus 30 and plus 90 degrees. Values between minus 30 and minus 90 will be left axis deviation. Values between plus 90 and plus 180 would be right axis deviation. And any value between minus 180 and minus 90 will be extreme right axis deviation, and that's sometimes termed superior axis deviation. So we'll consider the normal ranges in children in future content. Well, this is quite a complicated diagram at the moment, and I'm a believer in simplicity. So let's simplify it. To determine the axis, we only really need to consider these 2 leads, 1 and AVF. So how does this help us in working out the axis? Well, if the QRS complex in lead 1 is mainly positive, that means the electricity is flowing towards lead 1 like this. If, on the other hand, the complex is in a negative direction, that means the electricity is flowing away from lead 1, like that. The same is true in lead AVF, so the positive QRS complex means the electricity is flowing in this direction, and a negative QRS complex means the electricity is flowing in this direction. So we can work out roughly where the axis is going by looking at the QRS complex in lead 1 and AVF. So if lead 1 is positive, the electricity is going this way, and if lead AVF is positive, electricity is going that way. So they converge between 0 and plus 90 degrees, so we know that's where the axis lies. So in this example, lead 1 is still positive, but lead AVF is negative. So the axis is somewhere between 0 and minus 90 degrees. So to work it out precisely, we need to take a blank section of our ECG paper and draw a graph representing lead 1 and lead AVF. We already know from our approximation that the axis is somewhere between 0 degrees and plus 90 degrees. So to work it out precisely, we need to work out the net deflection of our QRS complexes. So let's do that for lead 1. So to do that, we need to work out the distance above the isoelectric line. So that's 1, 2, 3, 4, 5, 6, 7 small squares above the isoelectric line. that's 7. And it's half a small square below the isoelectric line. So to work out the net deflection, we need to take this, what's above away from what's below. So 7 minus 0.5 gives us 6.5. That's towards lead 1, so let's plot that on our graph there. We do the same for lead AVF, so we have 1, 2, 3, 4, 5 and a half above the isoelectric line, so we'll make a note of that, 5.5. And below we have 1, 2 small squares. So we take 2 from 5.5 to give us 3.5. That's also mainly towards the lead AVF, so we'll plot that on our graph there. So let's plot those lines, and the axis is where the lines converge, which is in this direction, just where we expect it to be. To finish off, let's work through the second example. So we draw our graph, and lead 1, we have 1, 2, 3, 4, 5, 6, 7 small squares above, half a small square below, that's 7 minus 0.5, which is 6.5, we plot that. And in AVF we have 1, 2 above, and we have 1, 2, 3, 4, 5 below, so we take 5 from 2 to give us minus 3, and that's away from lead AVF, so we'll plot that minus 3 here, join our lines and find our axis, just where we expected it to be. So I hope that's made ECG axis a little clearer for you. Thank you for watching.